In this video, we're looking at triangle congruence using side, 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 and side, angle, side. First, let's define congruent triangles. Triangles that have congruent sides and angles. So when we write a congruent statement for triangles, we must make sure that the corresponding parts are written in the same order. So in this case, we have triangle ABC is congruent to triangle DEF. A and D, B and E, and C and F correspond to each other. There are other ways to write this as well. As long as you're writing in the same corresponding order, it's okay. So CPCTC means congruent parts of congruent triangles are congruent. So basically this means if we know two triangles are congruent to each other, then the corresponding parts are also going to be congruent to each other, which means three sides and the three angles. Example 1. Are the two triangles below congruent? What are the congruent and corresponding parts? So angle A corresponds, it is congruent to angle L. Angle B is congruent and corresponding to angle M. And angle C is congruent and corresponding to angle N. We also know that side AB is congruent to side LM, side BC is congruent to side MN, and side CA is congruent to side NL. So we could say that triangle ABC is congruent to triangle LMN. Okay, the side, side, side triangle congruence postulate states if three sides in one triangle are congruent to three sides in another triangle, then the triangles are congruent. Okay, so let's take a look at example 1. Write a triangle congruent statement based on the diagram below. So we can see that triangle ABC has the three hash marks on there, the single, the double, and the triple hash mark. And it corresponds with the triangle LMK with the same hash marks. So that means that the corresponding sides are congruent to each other, and triangle ABC is congruent to triangle LMK by the SSS postulate. Okay, example 2. Write a two-column proof to show that the two triangles are congruent. So we have a couple of given statements and a proof statement. We can write the two given statements that segment AB is congruent to segment DE, and we can show that in our drawing. And C is the midpoint of segment AE and segment DB. So once I know that, I could say that segment AC is congruent to segment EC, and segment BC is congruent to segment DC, because that's the definition of a midpoint. So I can update my drawing here with my hash marks. So now look, I can say that triangle ABC is congruent to triangle EDC because all the corresponding sides are congruent. That's the side, side, side postulate. Okay, the next term is included angle, which states when an angle is in between two given sides of a triangle. So we have a diagram here. We see that segment AB and segment BC are the given sides, so that angle B would be the included angle. And this is important to understand the side, angle, side triangle congruence postulate, which states if two sides and the included angle are congruent to two sides and the included angle in another triangle, then the two triangles are congruent. So we see this in this diagram. We have two triangles that are given two sides and the angle in between them. So we can say that triangle ABC is congruent to triangle XYZ because of the side, angle, side postulate. So in example 3, what additional piece of information do we need to prove that these two triangles below are congruent using the side angle side postulate? So this is a multiple choice question. So part A, we're given these two angles are congruent, which doesn't work for us because we already have an angle. So part B, side AB is congruent to LK. That doesn't work. That would give us an angle, a side, and another side. For part C, side BC is congruent to side KM. Yes, this works because it gives us the two corresponding sides and the given included angle. So C is our answer. Well, let's just take a look at D really quickly. This would not work because this is two angles and a side, angle, side, angle. Okay, example 4. Write a two-column proof to show that the two triangles are congruent. So we are given that C is the midpoint of segment AE and segment DB. So that's our first statement we can write, and we can say that it is given. So if I know that C is the midpoint, that means that it's bisecting these two sides. So I can write that segment AC is congruent to segment EC, and segment BC is congruent to segment DC. And the reason is that's the definition of a midpoint. So now I'll update my drawing to show what's congruent. And then I know that angle ACB is congruent to angle ECD because these are vertical angles, and vertical angles are congruent. So update my drawing. Now I know that triangle ACB is congruent to triangle ECD, which is in the proof statement, and that is because of the side angle side postulate. Alright, last example, proving SSS and SAS in the coordinate plane. And we can do this by using the distance formula and comparing slopes as well. So what I'm going to do is mark x1, y1 as point A and x2, y2 as point B, and find the distance between the 2 points with the distance formula. So we've got a lot of practice doing this. Be careful about your substitutions and watch your signs. And end up getting root 41. So now I'm going to find the distance between D and E. Make my substitutions. Watch your signs here. And for this problem, for this distance, we get root 41 also. So that means that segment AB and segment DE are congruent, which is a good start. So now I'm going to test the distance between AC and the distance from D to F. So when I find the distance for segment AC, I get root 18, which simplifies to 3 root 2. And DF, we will find that we get a different distance. Square root of 13. So these are not congruent. Therefore, these triangles are not congruent either. Is there a graphical way of determining congruence here? I think by comparing the slopes and looking at the angles from angle A and D, you should have noticed that the slopes are a little bit different from A to C and from D to F, which would have been a pretty good indicator that that included angle was different. Alright, try the practice set.